Now in these notes, we're going to continue doing some practice questions with proofs, and it's still set up as the 2-column proof, so our statements and reasons, but instead of it being an algebraic proof, we are going to be using our angle relationships to prove some different things. So first, before we get into an actual proof, we just have a few examples of just from one step to the next of how do we get from one step to the next. So if we compare one angle and say that they're congruent, and now all of a sudden we say that the two same angles are equal to each other, so the measures are equal. Our reason for that is that our congruence implies equal measures. So the easiest way of writing that is writing a congruent symbol. Implies, remember, is our arrow, and then we can say our equal sign and then measures. The reason that you would do this in a proof is if we need to use an actual equation of something. So if we need to use 180 or 90 degrees, so in setting up an actual equation, if we know that two angles are congruent, then we need to say that they will be equal to each other, and this would be the reason that we would use. Next, if we go vice versa, so if we start with that the measure of the angles are equal to each other, and then we need to say that the angles are really then congruent, we just flip-flop this around, so it's really the converse of that. So we start with equal measures, implies congruence. So you have to think of what do you start with. The if is the hypothesis, so what we start with the equal measures, and then our conclusion is how it ends up. So it ends up being congruent. So pay attention to which is the starting point. So here it starts as congruent, and then it moves into equal measures, versus this setup is equal measures first, and then it is congruence. That's real easy to get those mixed around of which order you need to write them. So next for letter C is if we know that two angles are supplementary, then we can set up an equation for them. So angle 1 plus angle 3 is equal to 180 degrees. And our reason is based off of some of our definitions we saw in our first test. And our definition here is supplementary angles implies that the sum of the angles equals 180 degrees. And this is the way that we can write it. So supplementary angles, there we go, implies, there's my arrow for implies, that it has a sum of 180 degrees. So those are going to be ones that happen quite often, and we're going to actually go through the next proof together now. Now remember, when we first start off a proof, we want to look for any of the given statements. This line LM, so that's our L and M over here, is cut by the transversal line T. So that's this very first part right there. We also have that angle 1 and angle 2 are congruent, and that's also written right there. So we know that our first reason is going to be the given, and they just put them together. Sometimes you could see those two statements as two separate lines instead, so just keep an eye on that. All right, so then we want to look at, well, what information are we given so far, or that we see in the picture that we can then say that the measure of these two angles is equal to each other. So remember what we saw up at the top of your notes paper, this very first one, is when it changed from congruence to equals, and it was the exact same angles, that our reason was congruence implies equal measures, and that's what we're going to write right here for number 2. All right, so then for step number 3, we don't have anything mentioned already about 2 and 3 being supplementary up here, so sometimes you need to look at the picture. And we can see that 2 and 3 are a linear pair, and that's how they're set up. And because it's a linear pair, that tells us then that they are supplementary. So the picture itself is telling us that it's a linear pair, and that implies that those angles are going to be supplementary to each other. So now that we know that they are supplementary, then we can use that now to set this up, and that's what was mentioned up here. So if we say the two angles are supplementary, and now we can say that we can set them up to equal 180 degrees, here's the reason that we're going to use now for number 4. Now, when we say that measure of angle 1 and 3 are going to be equal to 180 degrees, that sometimes this is a little bit tricky one to figure out, but that's where you want to think kind of outside the box and ask yourself, what is different from step 4 to now step 5? So what changed? And the part that changed is this measure of angle 2 now is a measure of angle 1. So the question is, why is it switched out for the measure of angle 1? And that's because up here we know that the two measures are equal to each other. So we are basically taking our measure of angle 1, and since we know that the measure of angle 2 right here is exactly the same as measure of angle 1, I can switch it out. So I could substitute it for that other angle. And that's a trickier one to notice sometimes, so always ask yourself what's different, what changed from the previous statements, and that might clue you into what you need to look for. But now that we've seen that angle 1 and 3 are equal to 180 degrees, it's kind of the converse of this. So if we know first that it's equal to 180 degrees, we have the sum that's 80. And now because we know that, we can say that the two angles are going to be supplementary. So we're going to write the converse of this. So we're going to write the sum of 180 first, and then implies that the angles are supplementary to each other. Now for the last reason, sometimes we need to look at our picture, but if we are saying that now we can have enough information to prove that our angles our two lines are parallel, then we need to know a certain relationship. And since this was the last one, let's look in our picture. So if 1 and 3 are supplementary, we know that those two angles are considered our consecutive interior angles. And if we have those two types of angles, the consecutive interior angles are supplementary, then that gives us enough information to prove that two lines are going to be parallel, or that we have two parallel lines, and then that would be our last statement. For this last one, I'm just going to go through pretty quickly another example so you have another one filled out on your paper. Sometimes it's good to see this. So again, the very first part, we have our given. So not even being able to check our picture or anything else, I just know immediately that my given is going to be that first statement, and it's all it is. So next, angle 4 and 5 are supplementary, that we are given the reason for that is if we have two parallel lines. So if you look in our picture, angle S, or line S and line R are parallel already, and we have consecutive interior angles. So that would be my 4 and 5 right here, are my consecutive interior angles, and they are supplementary. Well, we have two parallel lines that we can then imply that the consecutive interior angles are going to be supplementary. So there's a reason of why now we can bring that part up. We know from previously, if we say that two angles are supplementary, then we can set them up into an equation as the measure of angle 4 plus measure of angle 5 is equal to 180 degrees. Our reason again is one we've seen before, and our supplementary angles, knowing that they're supplementary, then implies that we can set them up as an equation equal to 180 degrees. Now this next step, sometimes this gets a little tricky because all of a sudden now it brings up angle 5 is equal to, or measure of angle 5 is equal to measure of angle 6. But if you look previously, we had previously seen that they are congruent to each other, and now we're jumping down that they are equal. So all that change is it changed from your congruence into your equal measures. Then after we know that they are equal measures, we are seeing the reason is substitution property, and we saw that up above when part of our equation was switched out. So if we want to use our equation right here, 4 plus 5 equals 180, but our angle 5 now is equal to measure of 6, then I'm basically substituting measure of angle 6 in place of that part. Instead of the measure of angle 5, I am now going to put the measure of angle 6. So I'm substituting it in place of that part of the equation. But again, just like before, if I say that measure 4 and 6 are supplementary, my reason for that is because of the equation. And we know that the sum of those two angles is equal to 180 degrees, and that implies that we will have supplementary angles. Now, because 4 and 6 are supplementary in our picture, if you look at my part that I labeled in brown, and now we have these angle 4 and angle 6 are supplementary to each other, then we can say that our line L is parallel to line M because those are consecutive interior angles, and if they are supplementary, then we are going to have two lines that are parallel to each other.